Right, Concept X is going to be just for the honors classes. Regents we're going to bring up later in the year when it pertains to a particular topic. So with scientific notation, I'm going to go through some of the basics. You're going to see in your notepad there's a lot of empty spots. It's just kind of for you to decide what you need out of that section based on what your prior knowledge and experience is going into scientific notation. So by the end of this lesson, hopefully we're going to refresh your memory on how to convert to and from scientific notation, that you'll be able to add and subtract in scientific notation without the use of a calculator, and be able to multiply and divide as well. So scientific notation in chemistry, this is incredibly important for communicating data because it expresses a number as a multiple of a power of 10. So if I look at the mass of a carbon atom, is this really the most effective way in terms of time efficiency to express this number? And I think most people would agree that it's not, having to type in all those zeros every single time you talk about the mass. So how do we convert from a decimal form to scientific notation? I'm going to start with the number of 26 million. The very first step is to place the decimal point so that you have a one non-zero digit to the left of the decimal place. So 2.6, 2 being to the left of the decimal place. Count the number of places that that decimal point will have to move in order to get to that new location. So with starting with 26 million, it's going to take me 1, 2, 3, 4, 5, 6, 7 times to jump to this new decimal place. So if we move the decimal point to the left, which we just did, we make the exponent a positive value. So 26 million, which got moved to the 2.6, we jump 7 times to the left. Okay? So anytime you see this larger number greater than 1, you should be thinking about a positive exponent. In a different example, if you move the decimal point to the right, in order to get it to have that non-zero digit to the left of the decimal point, you are going to make the exponent negative. So 5.0, okay, we had to move the decimal point to where the arrow is on the screen. I had to go over to the right, let's see, 7 times, so we make it a -7 exponent. Okay. Scientific notation to decimal form, if the exponent is positive, you're going to move the decimal point to the right the number of places equal to the exponent value. So if I have 10 to the third, I'm going to move that decimal point 3 times to the right, so 1, 2, 3, to get my answer of 3010. If the exponent is negative, you're going to move the decimal point to the left. So -4 means I'm going to move it 1, 2, 3, 4 in order to get my answer of 0.000932. Okay, so again, that should be just a very brief review. I'll go over it with some individual students if needed. So just to kind of test to see where you are, see if you can try these out, and I'll give you the answers. For the first column, you should get 3.24 times 10 to the 6. The next one should be 7.60 times 10 to the -6. Just keep in mind, these zeros are not significant, so I'm not going to reflect them in scientific notation. However, this ending 0 is because of this decimal point out here, so I need to keep it in my scientific notation. And then moving right along, we get 2.0 times 10 to the -3, and then I'll show you converting to decimal form, going the opposite direction. You should be able to get these 3 values. And again, showing the same number of significant figures as the base part of our unit here, reflecting and carrying it over to decimal form. So again, if this is something you need more practice with, make sure you start it so that when I call you over in a small group, you'll know that you need to head there. Alright, adding and subtracting. I'm not going to spend too much time with this because I'm more focused on multiplying and dividing, but adding and subtracting numbers with the same exponents. Here we have both 10 to the 5th power. So I'm going to take the base part of that unit and I'm going to perform the operation that's between them. So 4.76 minus the 3.92, I get 0.84. I'm going to place that answer with that exponent or power of 10 that I had originally, which was 10 to the 5th. Now remember, we don't want to leave our scientific notation in this format. We're going to move the decimal point over to the right, so I'm going to drop down my power of 5 to a power of 4. And we'll go over that if that's confusing for any of you in class. Now, adding and subtracting numbers with different exponents. My personal preference is to take one of the exponents and change it so that it matches the other one. So in this case, I decide to take my 2.64 times 10 to the 7th and make it 10 to the 8th by sliding over that decimal point to the left. Once they are in the same exponent, and following the same rules up above. 5.84 plus, because that's my operation, or is addition, plus the 0.264 gives me the 6.104. Okay, and then you can go ahead and place that with the power of 8, so times 10 to the 8th. I should have, in this case here, have 3 sig figs and 4 sig figs. Just make sure you actually round that to the 6.10 so you're reflecting the correct number of sig figs. All right, multiplying and dividing. This is the big one and what I'll actually quiz and test you on. Much more on the exam. Step 1, you multiply the decimal numbers. Step 2, you're going to add the exponents. So when multiplying, you add the exponents. Step 3, put the new decimal number with the new exponent, and then making sure that you adjust where that decimal point is and your power of 10 as well if needed. So let's go through these examples. The new decimal, so I'm looking at my decimal numbers or my base numbers. I'm going to take those two numbers and I'm going to multiply them together to get the 17.16. My new exponent, I'm going to add the 6 and the 4. So 6 plus 4 gives me 10. My answer is going to incorporate my new decimal number and my new exponent. However, the 17.16 is incorrect in terms of my accepted format. I have to slide that decimal point over, which means that's going to affect my exponent. So your final answer is 1.716 times 10 to the 11th. My other two examples I'm going to kind of quickly go through. Multiply the decimal or base numbers to get 6.11. Add the two exponents to get 4, making sure you reflect that negative 5. And then plugging that in, you get 6.11 times 10 to the 4. And then the last one, again, multiplying the two decimal numbers or those base numbers, making sure that you add the exponents together, and then completing your final answer in decimal form, which is 5.32 times 10 to the 12th. Alright, so again, if this section in particular gave you issues, make sure you start it so that you can work with me one-on-one tomorrow. So, dividing in scientific notation, very similar to multiplying, except that instead of adding the exponents, you're going to subtract them. So let's look at examples. Here we're going to be dividing these two numbers. Our new decimal is dividing the two decimal numbers, or those two base numbers, and instead of adding, we're going to subtract 9 from 3 to get 6. And then I put this all together for my final answer. Same thing with the second example, we're going to divide the two decimal or base numbers to get 3.1, and then subtract 8 minus 5, or subtract the exponents to get a number of 3, and then combine it for 3.1 times 10 to the third. And then finally, in our last example, still dividing our decimal or base numbers, so 6.4 divided by 4 to get 1.6. We're then going to subtract the two exponents, so negative 4 minus 6 gives us negative 10. That's probably the trickiest one out of this group. And then placing that together to get 1.6 times 10 to the 10th. Now, initially we're going to just work on these single operations like we just did in the notes, but then eventually we're going to progress to multiple functions in the same problem. So we're going to kind of do this increasing in steps. So as of right now, just to kind of see where you are before you come into class, complete these 3 questions. I'll give you the answers and we'll come back to them at the start of class tomorrow. So A, if you paused it and answered them, you should get 4.70 times 10 to the negative 4th. B, you should get an answer of 1.9 times 10 to the 23rd. And C should be 3.0 times 10 to the negative 1. So again, this should maybe give you an indication of what section above you might need to review more with me tomorrow. Great, that is it. So honors, you are completed Unit 1, you are all set, and we'll finish up scientific notation over the next 2 days in class.